In this video, we are going to study an important concept called as cumulative distribution function and probability distribution function. So let us start with the first cumulative distribution function. In short, it is denoted as CDF. So let us begin with the definition. So CDF, cumulative distribution function, or it is also called as cumulative density function. CDF is defined as probability that a random variable capital X, random variable is denoted as capital X. This random variable takes value less than or equal to small x. So simple definition, CDF is a distribution function and it is defined as the probability that a random variable will take, and this probability will have value less than or equal to small x. So it is denoted as capital F suffix capital X of small x, and it is given as fx of x is equal to probability that random variable capital X has value less than or equal to small x. So this is the definition of cumulative density or distribution function. Next, we are going to see the properties for this CDF. So the first property, the value of CDF is always between 0 and 1. So we can denote it as CDF lies between 0 and 1. Second property, value of the CDF function at minus infinity is 0. Third property, value of CDF at plus infinity is 1. Next property, if we have fx of x1 less than or equal to fx of x2, then this function is non-decreasing function. Next, fifth property, if we want to find out the probability of x, which is a random variable, greater than small x, this can be obtained as 1 minus probability of random variable x less than or equal to small x. So this can be denoted as 1 minus fx of x. So it is like the CDF is nothing but probability of random variable x less than or equal to small x. So if we subtract it from minus 1, we get the probability of random variable taking values greater than small x. Next property is, if you want to find out probability of a random variable between x1 and x2, this can be obtained as CDF of the higher value, that is x2, minus CDF of x1. So these are the properties of CDF. Now next, one equation we have to go through, which we need to solve numericals. So it is the equation for discrete CDF. So it is very crucial equation. So the discrete CDF equation is represented as fx of x is equal to, so this CDF takes different values. First is 0 for x less than x1. It takes value summation I equal to, just make one correction over here, so x less than x0, so we can start with 1, so summation I equal to 1 to n for the range x lies between x1 to xn, and last this value is 1 for x greater than xn. So this is again very important equation we should remember, which is regarding discrete CDF. Now let us move on to the next topic, which is the PDF. So it is probability distribution function. It is denoted by PDF. So we can define this PDF as it is derivative of CDF. So simple definition, PDF is derivative of CDF. So in equation form we can write it as, or it is denoted as, small f of capital X into small x. So remember, PDF is denoted by small f and CDF is denoted by capital F. So here we have the equation as small fx of x is equal to d by dt of, it is not dt, d by dx of capital fx of x. So here this fx of x, small fx of x denotes PDF, and here capital fx of x denote CDF. Now let us see the properties also. Properties of PDF. First property, so this PDF is always greater than 0. So fx of x is greater than 0, greater than or equal to 0. Second property, if we integrate this fx of x from minus infinity to plus infinity, fx of x dx, its integration is 1. Third property, to find out CDF, that is fx of x, from PDF, we need to integrate this PDF from minus infinity to x fx of x dx. Fourth, if we want to find out probability of a random variable between x1 to x2, in this case we can use the equation of PDF as integration from x1 to x2 fx of x dx. So these are the prominent properties of PDF. So here we have seen the definition of CDF, its equation. It is denoted by capital Fx of x. It is cumulative distribution function, which is equal to probability of a random variable taking value less than or equal to small x. Then we have gone through the properties of CDF, and then we have gone through the equation for discrete CDF. Then we have seen the definition of probability density function. It is PDF, it is derivative of CDF, and its properties.